of real-life application that takes place in this here. So the question today about solving rational equations, how do you do just that? How do you solve a rational equation? So in order to be successful with this, we first of all have to be able to what, kids?
Solve rational equations by cross-multiplying.
We already know what cross-multiplying is, don't we? Okay. We also want to solve rational equations by using the... Do we know what a least common denominator is? We know that. We can figure that out. And then we're going to use some inverses of functions to help us today. And we've talked about inverses in the past. So I think most of the terminology that's up there, that's going to be good for you. All right? Vocab-wise, let's talk. Cross-multiply. What does that mean? How about volunteer to read that?
You can use cross-multiply to solve a rational equation when each side of the equation is a single rational expression.
And when I say single rational expression, that means just one bar on both sides. Now keep in mind, we're talking equations here now, kids. We're talking equations, so we might be looking at stuff like this. 3 over x plus 7 equals 6 over x minus 5. On the left and on the right, do we have rational functions? Both are written as a fraction, right? Is there just one bar on the left and on the right? Could I use cross-multiplying then? I could. How about this? I'll come back to this. If I had this. Hey, quick question. Can I cross-multiply there?
No, you can.
Why not?
Two fraction bars.
2 fraction bars on the left. We would have to work this out a little bit to make this so that it was how many fraction bars first? Okay, and we're going to talk about how to do that, okay? And it works out to be pretty slick. So understand cross-multiplying is only going to work when you have 1 fraction bar on both sides, okay? Guys, proportions. You know what proportions are. They're 2 equal what? So like this, 1/2 would be the same as 4 over what, kids? Okay, and just think about this. Look at your cross products. 1 cross product is 1 times 8, isn't it? What's that equal?
8.
What's 2 times 4 equal? And you've already told me if I had something like this, if I had 6 over x equals, 18 over 72, you told me the order for this would be what times what first? 6 times 72 divide. Okay, so that's nothing. You've seen that, right? Guys, in the past, when we dealt with a lot of quadratics and the quadratic equation, we come up sometimes and say, oh, by the way, these solutions, extraneous. You guys remember what extraneous solution meant? Okay, it meant that we went through all the rules of algebra and we got some answers by all the rules of algebra. But when I took some of those answers and plugged them back into the original equation, they made the statement what type of a statement? False. Okay, so any solution that you get by rules of algebra that after you substitute back into the original ends up false, those are considered what kinds of solutions, kids? Extraneous, and we'll talk about them. They're like solutions that do not work, a solution that does not work in the original equation. It's as simple as that. Okay? And then lastly, inverse of a function is a function that replaces inputs and outputs. Suppose I have this. If I have this machine that's called the function machine, I drop a 3 in and it kicks out a 7. Okay, I dropped a 3 in and it kicked out a what? 7. So if this was a true invertible machine, I would drop a 7 in and it would kick back out my 3. It would just work backwards to give me back what I originally had, right? Make sense to you? Okay, so I think we know what those are. So let's get into this first example and talk. It says, first of all, solving a rational equation by doing what, kids? Cross-multiplying is only going to work when you have an equation of rational functions where on the left side and the right side there's how many bars?
1.
Are we good to go on the left?
Yes.
Are we good to go on the right?
Yes.
Yeah, there's 1 bar on each side. So I'm going to say 1 bar each side. You know what I say to that? That's goody. That's a good thing. Okay? That's a good thing. That's a good thing. hope you're not grading my art. I would get a U. Unsatisfactory. Guys, anytime you're talking x plus 2, 3x plus 2, when we cross multiply, you might want to consider these to be in what? Okay, so let's start this real quickly, guys. One cross product is going to be 2 times what?
3x.
Okay. That would equal my other cross product of what?
10 times x.
Okay, guys, talk me through this. First of all, I've cross multiplied. I've got one cross product equal to the other. The reason I could cross multiply is because there was bars on both sides, fraction bars on one side, but more specifically, there was just one fraction bar per side. So it just becomes a simple algebraic equation with variables on both sides. Help me distribute up here.
Wait, so the cross products are going to be equal?
Yep. Let me go back to an example right here. Do you agree that 1/2 is the same as 3 over 6, Sophie?
Yes.
Check it out. What's 1 times 6?
6.
What's 2 times 3?
6.
Find what I'm selling there?
Yes.
Okay. So if I back up here, down there in that example, we would say 2 times what here? That first cross product would equal the second cross product. So by distribution, what's my left side going to be, kids?
6x plus 4.
Equals,
10x plus 20.
in unison, 10x plus 20. Kids, I don't like this 10x over here. Can I get rid of it? By subtracting both sides, you okay with that? Guys agree that this is negative 4x plus 4 now?
Yes.
You agree that this is 20 over here? Subtract 4. So I've got negative 4x equals what? So how about 16 divided negative 4?
4. Negative x.
Yeah, so I end up with x equals negative 4. Now, kids, the thing that I want to point out, 2 things. Why was I able to cross multiply right off the bat here?
Because there's one bar on each side.
Okay, we're good with that. When I solve for x, then, by rules of algebra right here, we always, especially when working with rational functions, have to make sure we check our answer. The reason we have to check answers is because if you're dealing with rational functions, you never want to have what value on a denominator. You never want 0. We say it's all fun and games until somebody starts dividing by what? So jump up to your original problem, kids. We think negative 4 is the solution, right? Okay. What's negative 4 plus 2 going to get you in a denominator here? Negative 2, right? So are we good to go there? Is it okay to have a negative 2 down here? How about I plug negative 4 in here? What's 3 times negative 4 plus 2? Negative 10. You're on your way. There you go. Easy. Okay. Now I want to show you the application that comes with decimals to this. You guys are going to help me. What does the left-hand side of the equation say? 2 over what?
X plus 2.
2 over x plus 2. What did the other one say?
10 over 3x plus
Plus how much?
2.
Hey, these graphs cross at all? Where?
Well, that one crosses at negative 4.
Well, my gosh. What do we get for a value? Makes sense to you? Right, just keep that in mind, all right? I wish everything was as simple as graphing or as simple as just cross-multiplying and solving, but it's not. Next page here, I really like this next example. I think this next example is awesome. How about a volunteer to read this for me?
I'll read it.
Okay.
White gold is an alloy composed of 75% gold and 25%
I think it's palladium, isn't it?
Palladium by weight. You have 12 ounces of an alloy that is 60% gold and 40% palladium. How much pure gold should you mix with this alloy to make white gold?
Okay, somebody Google up what is palladium.
I got it.
Hey,
I'm on it.
Iris.
I'm on it.
Ouch.
And the second question is,
What is palladium?
A layer in rustorous silvery metal. Lustrous.
Lustrous. I asked Iris and she just said Poland.
you called her Iris, I love it. So palladium is like a what?
A silvery white metal.
Thank you. Silvery white metal. So white gold, think about this. What do you think? What do you think is gonna, so it's a silverish kind of metal, right?
Correct.
You know, when you talk about metals at the Olympics, which metal is more precious, a gold or a silver? So do you think that rings like this that we're talking about, or whatever we're talking about, what is this? White gold, you use, we're just mixing it, right? Do you think it becomes more precious or more valuable if you add more gold or more palladium here? More gold, right?
Gold is the good stuff.
Gold is the good stuff. So here's the deal. It says that you have white gold when what percent of your alloy is gold?
75.
When 75% of it's gold. Well, it says in here, kids, you have how much of the mix do you have? Okay, so our total right now, our total of the mix, our total mix is 12 ounces, right? Okay. Now, guys, of those 12 ounces right now, what percent of that is gold? 60%. So my question is, could you figure out how many ounces of the 12 are gold? If 60%?
Probably 7.
Pretty close to 7. I could just take 60% of what value? Do that for me. Take 12 times, take 12 times 0.6 for me.
7.2. I was pretty close.
Okay, so this is 60% gold right here, right? Now listen carefully, kids. We have gold and we have palladium mixed in here, forming 12 ounces. When I have 7.2 ounces of what? That's 60% of the total mix. Now, kids, I want to take 60% and I want to add some more gold to this so that the ratio is not 60 to 40, but rather 75 to what?
25.
Okay, now here's the deal. What are we adding?
Gotta add gold.
We got to add gold. We got to make 60 go up. Now, if I add a certain amount of gold to the 7.2 I already have, what happens to the overall 12 ounces that we have in there as a mix?
It goes high.
It's going to go up by the same amount. So whatever I add to 7.2 here, kids,
You gotta add 12.
I got to add to 12. So I'm going to let X be the amount of gold that we're going to add in ounces. And I want this to equal what value in the end, kids? 75% as a decimal would be what? Can I call that 0.75 over 1 then? Is that okay, kids? Okay, now let's think about this. Again, where'd the 7.2 come from?
How much?
It's already in it.
60% of my 12 ounces, or 7.2 ounces, is the amount of gold already there, right? By the way, if I took 7.2 and divided it by 12, what do you think you'd get? 0.6, 60%. We want we want to add some gold to the amount that we have in here already, but we also know that if I add gold here, that changes our total 12 ounces right here. Guys, doesn't this look like a rational function?
Yes, it does.
I have a question. Can I use cross multiplication to solve what I've modeled here?
Yes.
Why?
Because it's all in one. There's one bar on each side.
One bar on the left, one bar on the right. All agree?
Yes.
Let's do the first cross product. First cross product, we'll do 7.2 plus x times 1. Well, that's easy.
7.2.
Okay, help me on the right. What's 12 times 0.75?
8,
Close.
9.
9 plus. You guys agree 0.75x? Okay. Let's get the x's together. So I'm going to subtract 0.75x from both sides. So 1x minus 0.75x would give you what? So this is 0.25x on the left. It would really be 0.25x plus 7.2. But so let's do 9 minus 7.2. What's that equal? 1.8. All right. Guys, x is going to represent the amount of gold we have to add to what's already in the mix to turn this to a 75 to 25 ratio.
Whoa.
How many ounces do you get there? What's 1.8 divided by 0.25?
What? 7.2.
7.2.
So you have to add like.
So you have to double the amount of gold to turn that to 75%. Let's just check this. You guys agree that this would become, how many ounces were in there originally? And we added 7.2 ounces to the gold that was already in there. But the total mix was 12 ounces, and we also added how much more to that 12 ounces? So you guys really agree that, see, 7.2 and 7.2 would be 14.4, wouldn't it, kids? And now our weight is not 12 ounces anymore. It's, boy, with a little bit of luck, the amount of gold that we have, 14.4 ounces, to the total weight, 19.2 ounces, should divide out to be what decimal? 0.75. See if that's true. Mind blown, right? 7.2 ounces, okay? All you got to do is figure out how much gold did I have, how much is the mix. We're going to add a certain amount to both the gold and the mix, but it's going to be the same amount. That has to equal whatever your ratio is. Once we saw that I had one fraction bar on the left and one fraction bar on the right, we were off to what process? Cross multiplying and solving, okay? So 7.2 ounces is what we would need to add. So when we added 7.2 ounces, this alloy compound became what? White gold, because 75% of it was pure gold, okay? And your ring or whatever you're going to make out of it just got twice as expensive. So 2015. All right.
You know what's really 2015?
No? That was 2017.
21.
When were the fidget spinners? 2016? All right. Well, let's talk, kids. Let's keep moving on. Example 3, this is where I start to have concerns. Okay? This is where I start to have concerns. So I think that you should put a star by example 3. Okay? Ready for this one? Okay, I'm going to divide this like so. I think you should do the same thing. I think you should do the same thing here, kids. Okay, I'm going to divide this so I have room to work up top for A and work for the bottom. Okay, here we go. Kids, first of all, the directions up by example 3, solving equations using what? The least common denominator. Now, kids, first of all, can I just jump right into cross multiplying here?
No, you cannot.
Okay. So what ends up happening in something like this is maybe I should back up. Why can't I just start cross multiplying?
2 bars.
And there's 2 bars on the left. So here's the deal. We need to work with the left a little bit to get that down to what? 1 bar. Now, guys, equations are very different. If you remember when we were simplifying stuff, if I multiplied the bottom by 1 value, I had to do the same thing to the... That's not necessarily the truth when we start talking about equations. If I have an equal sign right here, if I would multiply the left by 2x, I keep it exactly the same if I do what to the right? 2x. You guys have known rules of equations since, I don't know, 5th grade. Whatever I do to one side, I have to do the same exact thing to the other side. So here's what happens here. This is a pretty nifty little trick. First of all, let's talk. Look at all your denominators here, kids. You have some x's and you have some 2's up there. What would the least common denominator of x, 2, and x be? What would your least common denominator be? 2x. Agreed? Everybody agree?
Yes.
So watch what I do here. I am going to go ahead and multiply each term by the least common denominator. You multiply each term by the least common denominator. So what ends up happening here is this. This 3 over x, kids, take it times your least common denominator of what? Okay. This 5 over 2, kids, that plus 5 over 2, take it times your least common denominator of what? Have I multiplied everything on the left side by 2x? The equation stays balanced if I multiply everything on the right by what? So let's see what we have here. This would be the same as, well, what did you have on the right, kids? Whoops. Negative 12 over x times what?
2x.
Let's see what happens here. Guys, 3 times 2x divided by x. 3 times 2x divided by x. Anybody want to take a guess on that?
6.
It's just 6 because the x's do what to each other? How about 5 times 2x divided by 2?
5x.
So 6 plus 5x. Wait a minute. You're telling me that stuff dropped out so there's no denominator here? You're telling me that stuff dropped out so there's no denominator here? Nah, this is too good to be true. What's negative 12 times 2x divided by x?
Negative 24.
Just negative 24?
Yeah.
No denominator?
Oh my gosh.
Stuff just dropped out, right? A problem that was pretty difficult just became what, kids? Pretty easy, didn't it? And it became pretty easy because we had to multiply everything by the least common denominator. Least common denominator makes the denominator do what multiply, kids? Makes it go away. I don't care what the expression is, it makes it go away. Now, why did I have to use least common denominator here? Well, there were multiple bars on the left. Okay? So, is that pretty easy to solve now? What are you going to do to both sides? You got it. You bet. So, 5x would equal what? 5x would equal negative 30.
And then divide by 5 and x is negative.
I have a question. Anybody see a shorter way of doing that one? Keep in mind, I've been doing math for almost 40 years.
I don't know, could you have subtracted 3 over x from that side?
I could have. Why could have I gotten away with that?
Because they both have the same.
Some of you may have noticed that the same denominator x existed here, so I could have subtracted this, and this would become negative 15 over what, kids? Just check this. Just do this. Everybody see what she's talking about? If you ever see like a common denominator, try and get them together right away on either side of the equation. So you could have called this, what, 5 over 2 equals negative 15 over x? Well, help me out. What's negative 15 times 2? Negative 30 divided by 5? That was a lot faster. So keep your eyes open. If you ever see something that's like, ooh, there's an x here and there's an x here, maybe I can put them together somehow. I mean, negative 12 over x, if I subtracted 3 over x from both sides, wouldn't that make this negative 15 over x? And what would have been left over here if I moved this out of here? Well, 5 over 2, right? So, yeah, you could have done that, all right? Now, my question is, are we going to be able to get away with that in the next example? No, absolutely not, because, oh, lordy.
No common denominators here.
No common denominator here, which means if there's no common denominator in anything, the least common denominator is, all right, let's talk about least common denominator. Can 1 be broken any further? No. So we've got a bucket of 1s to choose from. Can x minus 4 break any further?
No.
You got an x minus 4 bucket to choose from. Can x be broken any further?
No.
Guys, where are you taking your 1s from? Here. Where are you taking your x minus 4s from? Where are you taking your x's from? Okay, so we're going to multiply basically everything times, well, multiply by 1 is an identity. So aren't we really taking this, aren't we taking everything times x minus 4? Okay, so watch what I do. The 1 part, kids. We're going to take 1 times what first? You guys agree with that first part?
Yes.
What am I going to take? Minus 2 over x minus 4 times. And that's going to equal 4 over x times what? Okay, we've got a mess here, don't we? Quite frankly, we have a mess. Let's deal with that first part, which is the 1 times this. Okay, what's 1 times x going to get you? Okay, so let's deal with this here. 1 times x is x. X times x minus 4. Let's distribute that. So this would be, to begin with, what? Okay, x squared minus 4x. Okay, that's the first part. The next part was minus 2 over x minus 4. Let's look at this. Guys, minus 2 over x minus 4, but guys, we're multiplying by an x and what else? Ooh, that's exciting because what can happen there?
Oh, you can.
My x minus 4s are going to take a hike, aren't they? So this is just really going to be minus what? Okay, are you with me there?
Yes.
Then this will equal on the right. Okay, anything going to drop out on the right where I have 4 over x times x minus 4? The x's go away. That's always a good thing when the x's go away. So you got 4 times x minus 4, but if I distribute correctly, that would be 4x minus what? Okay. Least common denominator is kind of goofy. X times x minus 4, but when I multiplied everything times x minus 4, are there any denominators left anymore? Is that a good thing or bad thing? So we've got some work to do. How about the minus 4x and the minus 2x? Would that combine?
Yeah.
Yeah, I see that as x squared minus 6x. Now guys, what I'd like to do, I see an x squared up there. This is probably going to become quadratic formula or some kind of quadratic. I have to factor and solve. So let's do this. Do you guys agree that the left is x squared minus 6x? Let's minus 4x from the right. So negative 6x, drop it down 4 more x, where are you at? And then how are you going to get this negative 16 out of here? Yeah, so we really have x squared minus 10x plus what, kids? Okay, so this is where things come back to that idea of factoring that we spent a little bit of time on. What's 1 times 16, kids? So can you think of factors of 16 that produce negative 10 somehow? Okay, how are 8 and 2 going to work?
Negative 8.
Negative 8 and? So this factors into x minus 8, x minus 2, so if I look at that x minus 8 part, what value x is going to get you to that quantity of 0?
8.
So one solution here would be 8. What's the other one going to be? Okay, now kids, again, when you get done, do you just assume done? What do you have to do?
Check your answer.
And when I really say check your answer for adding or irrational equations right here, we're really asking, is there any value that would go in for x to make your denominator? Are the values 8 and 2 going to make any of these denominators 0? What would have to go in here? What would have to go in here? Well, I don't have 4 and 0. I have what and what? So are they going to work for us? Okay. Now, do you think that's always going to happen? Every answer is just going to work? Or do you ever think there might be a time when there's extraneous solutions?
Probably always a time.
Going to be a time. And I tell you what, let's end with example 4 today. If we get through example 4, I'll feel really good about how far we got today, all right? Wouldn't you know it? Example 4 is solving an equation with what?
Extraneous solution.
Okay, let's talk about what this means. First of all, this problem is kind of a nightmare. Okay? So I'm going to rewrite this a little bit. I have no idea, first of all, what the... let me go all the way back to the beginning. Can we just start by cross-multiplying?
No.
Why not? 2 bars on it, right? That's a bad thing. Okay? Okay. Maybe it would be wise then to find a what then? Okay, I'm not sure about this right here, so I'm going to rewrite this, okay?
Can you factor first?
We could.
Alright.
Okay, let's talk about this one. X squared minus 9 is going to factor into, anybody know it?
X minus
X minus 3 and what else?
X plus 3.
Excellent.
X.
How about the next one?
X minus 3 and X minus 2.
Absolutely. How about this one? Okay, can I cheat this problem a little bit with you? Is that okay? I don't want to say cheat this. I maybe present it in a way that you might think about it a little easier as you have to go through the process yourself. Okay, we have 3 different parts, kids. Factored form on the left is this. Factored form in the middle is this. Factored form on the right is this. It's like saying we have 3 buckets to choose from. But it looks like the only things that we get to choose are some x minus 3s and some x plus 3s. So my first question is, where are your x minus 3s coming from? First one, second one, or third one?
First and second.
Well, they are, but I want to take them in a situation where I have the most. So I'm going to take the x minus 3s from the second, which means you can't have that. Okay? So I'm going to put my least common denominator up here for this problem. And I'm going to tell you why I'm putting it up here. Our least common denominator is going to become the following. It's going to become x minus 3 times x minus 3. So we took these 2 and we said if I take those 2, I can't have that one there from that bucket. Now, what else are we allowed to choose?
X plus 3.
Doesn't matter where that one comes from right now, where we're at.
No.
So maybe we take this one and say we can't have this one. Okay? All right, listen to what I say here. Do you guys understand how I got the least common denominator of x minus 3 times x minus 3 times x plus 3? Okay, which means we're going to take every part times...
Hey, wait, how'd you get the LCD?
Tell me again, guys, why did the x minus 3's come from this part right here? Why 2 of them? Because it's the most. There's 2 here, there's 1 here, and there's 0 here. Well, you got to at least cover your factors, so you've got to cover these 2 for sure. I don't take this one right here because this x minus 3 already covers that x minus 3. So we know that we have to take at least 2 x minus 3's out. Okay? So that's why they go up there. So if I took that, I can't have this one. Then the x plus 3, there's 1 here and there's 1 here. We've got to take 1 from somewhere, and I took it from here, meaning I can't have that one. You always take the most when you factor stuff down, okay? So whatever you circled is what becomes the least common denominator. Now watch what happens here, kids, and I want you to listen carefully. Do you guys all agree that this problem, and I'm going to rewrite it over here, do you all agree that this problem was originally 4x over, what did we factor this first one into?
X minus 3, X plus 3.
Okay, I'm going to show you how to cheat this a little bit, and I'm going to get my red marker out here. Okay, here's the deal. Least common denominator makes all of the denominators fall out when I do this method, right? Okay. The x squared minus 9 factored into x minus 3 and x plus 3. And now I'm telling you, we're going to take this first part times this mess. But let's think about it, kids. If I take this first part times this mess, what would fall out from this up here that I'm about to multiply by? And what else would fall out? So what I end up doing is I say, okay, this and this are going to take these 2 out, meaning I really just need to take that 4 up top times what?
Shouldn't it be 4x up top?
Should it? Yep.
Oh.
Hang on a second. Be 4x, right? So I'm really saying, hey, this is going to drop out, This x plus 3 would take this out. This x minus 3 would take this out. So what do I really have to multiply the 4x by? X minus 3. Okay, let's go on to the next step. We really had x minus 1. What was that, an equal sign there, kids, in between? We really have x minus 1 up here over, what did this factor into? X minus 3 and what else? Okay, well, here's what I'm going to tell you, kids. This x minus 1 up here needs to get multiplied by this whole thing, but since there's two x minus 3's on the bottom, they would cancel that when I multiply, which really means what? You're really going to have just the top. These are going to go away because they're going to take this and this out, right? And you're really taking x minus 1 times what? Okay, see what I'm doing here? Then this last one was just what down here, kids? Well, this x plus 3 is going to take out the x plus 3, which means if this takes this part out, here and here, that 2 is going to get multiplied to what? X minus 3 and what else? So you're really going to have plus 2 times x minus 3 times x minus 3. Again, keep in mind, what's happened to all my denominators? They've gone away. Okay? So let's take a look at this. Help me distribute on the left.
Hey, wait, question.
Yeah.
So the step you just did, the 2 times the x minus 3.
So this x plus 3 only takes out what?
The x plus 3.
Means I've got to take that 2. What was left up there of my common
You just
denominator?
have written up an x plus 3 and an x minus 3.
Oh, it should be x minus 3, shouldn't it? Hang on a second. I'm back. So this should be minus 3 right here. Okay? And these are gone. So here's what we've got. Is that what you're at, Sophie?
That's
Thanks for
why.
catching it. I appreciate it. Okay, help me distribute on the left. What have I got?
4x squared
Yep.
minus 12x.
Equals. All right, help me FOIL this. What's x times x going to get me? Okay, inside, outside. So the inside would be minus 1x, outside plus 3x. What's a minus 1x and a plus 3x going to combine to? So positive 2x. Last, negative 1 and 3. Okay. Kids, I'm going to tell you this right here. This is the same as 2 times x squared. Let's see, inside would be negative 3x, wouldn't it? Outside would be negative 3x, so minus plus what? So we need to take all that times what's still up front here.
2.
Okay, so this would be plus 2x squared. 2 times the negative 6x would be
Minus 12x.
plus. Okay. This is getting pretty interesting, but we're close now. Again, multiplying by the least common denominator, what did it make go away? Denominators go away, that's a good thing, right? I mean, denominators are bad, bad people. You want them to go away. Once the denominators go away, then things get pretty interesting and pretty easy. Let's simplify some stuff. The left is still 4x squared minus 12x. All agreed? How about on the right side? How about the 1x squared and the 2x squared? I have a 2x and a minus 12x. So wouldn't that be minus 10x? And how about minus 3 and positive 18? Okay, again, the thing that jumps out at me is that this is x squared. This is some kind of quadratic. So in the end, you're probably going to have to do what? You're going to have to factor stuff, but factoring works really nice when stuff is equal to what?
0.
So let's get everything to the left. So help me subtract 3x squared. What's 4x squared minus this 3x squared? So I have 1x squared. Help me with this. This would be negative 12x. I'm going to move this over by adding 10x to that. So negative 12x plus 10x. And then this positive 15 we need to subtract from both sides. Well, there's nothing here, so it would just be what over here? All right, so talk to me, kids. What's 1 times 15? 15. Can you think of two whole factors of 15 that get you -2 somehow? 3 and 5, and how are you going to set that up, Kylie? So you're saying this factors into x minus
5.
Okay, so let's talk. What would go into this first quantity to make that 0? +5. What would go in here to the second quantity to make that 0? Okay. Now just because I think that these are the solutions doesn't mean that we better just sit on it. What should we probably think about doing? We probably better back substitute that and see if that's truly the case. All right? Not a big deal. It's not a big deal. Go back to your original problem.
That looks like a newspaper.
That's okay. You know what? If you create a newspaper, it's like you've written something great and it got published and it's art and it's something important. There you go. Okay, help me out with this. Let's plug in 5. What's 5 squared? Is 5 going to make any of this 0?
I don't know.
25 minus 9 going to be 0? No. Is 25 minus 30 plus 9 going to be 0? No. Is 5 plus 3 going to be 0?
No.
Is 5 okay? How about -3? -3 squared is
9.
minus 9?
0.
Uh-oh.
Extraneous.
So, yeah. -3. Here's what we say about -3. We like you all the way through here, but you know what? It's down to finding out who the true bachelor is going to choose. And bachelor chooses 5. So 5 gets through, -3, take a hike. All right? This one is okay, right? What can I call this one? Okay. Brett, I want to tell you, in 20 years of teaching, I've never been referred to Parsons as like a newspaper. Okay.
Announcement, a reminder, anyone wanting to attend the ACT math prep class in Mr. Parsons' room starting at 7:15 a.m. tomorrow. Also, phone students, please stop by the office before leaving today. Josh Bechtold, Brian Sedgwick, Britt Ross.